We've been studying the logic of categories, categorical logic. Categories are the elements inside statements, and we've been talking about the relationships between them. So we've been talking about statements in terms of what is inside of the statements. Now we're going to shift to propositional logic, where we're talking, the smallest unit we're talking about is now an individual statement itself. Propositional logic is also typically what we have in mind when we talk about symbolic logic. Symbolic logic because what's happening is we're beginning to symbolize the relationships between statements. So instead of using the English words if A then B, we would write A horseshoe B, where the horseshoe is going to stand for is going to be the symbol standing for if then. Capital letters stand for simple sentences or simple statements, and a simple statement is an affirmative statement. So the capital letter W could stand for it's warm in here. If you want to say yesterday it was not raining, that would be considered not a simple statement but a compound statement, and it would require not just the letter R for it was raining, but the tilde, the word not, or the negation, which is represented by a tilde in symbolic logic. So symbolic logic because we're going to use a few symbols, and in fact there's only 5 of them. So the capital letters symbolize simple statements, and then there are 5 symbols that stand for the other operators that can affect statements. And in English, these come down to not, and, or, if then, and if and only if. They're called truth functional operators because they determine the truth value of the compound statements that result when you combine the operator with one or more statements. So if the statement Clinton had bypass surgery is true, then the statement Clinton did not have bypass surgery is going to be written tilde C, and it's going to be the opposite. It's going to be false. It's a truth functional operator because it lets you calculate the truth value of a statement. We use the lowercase letters P, Q, and R to stand for, to operate as variables, which means they stand for any possible sentence. And so for any sentence P, tilde P always has the opposite value of P. Here's a simple little truth table that shows that when P is true on line 1, tilde P is false on line 1. And when P is false on line 2, tilde P is true. So here are the meanings of the tilde in English. There are a variety of ways you can negate sentences. You can say no, not, never, it's false, that. So tilde J would stand equally well for John didn't finish his homework as for it's false that John finished his homework. The dot represents conjunction, and that means we're asserting 2 things at the same time. Again, in English there's a variety of ways of doing that, and, but, however, although, moreover, and even the semicolon all do that. So G.S can stand for all 3 of these sentences. Garfield and Snoopy are dogs. Garfield's a dog and so is Snoopy. Garfield's a dog but Snoopy is too. In all 3 cases, 2 things are asserted. One is represented by G, Garfield's a dog. One is represented by S, Snoopy's a dog. Apple and Ford both make computers. We can represent that by A.F. This tilde in front of the entire statement, putting the statement in parentheses and the tilde in front, would now say it's false that they both do, or not both of them do. If the statement is true that Apple makes computers and false that Honda makes computers, then these are the truth values. Joined by the dot, that's going to make a false statement because the claim is that both are true, but one of them is not. So the claim that both are true is false. And a conjunction is true only if, in fact we can say if and only if, both statements are true. Here's what the truth table for that looks like. If both statements P and Q are true, then the conjunction of them is true. But if one of them is false, the conjunction is false. And that's the case regardless of the order they come in. And if both of them are false, then again, the claim that they're both true is wrong or is false. And this is called the truth table definition of the dot. Another simple symbol is the wedge, which represents either or disjunction. There are not that many ways to say either or in English. Basically there's 3, either or without the word either, and unless, which also means if not. Either Bill or Jane will get elected, Jane will win unless Bill does. So the or represents either of those expressions, either or unless. Now, or has two meanings in English. It has a weak inclusive sense and a strong exclusive sense. Jones is either going to get a raise or a promotion. Is weak because he can get both. Strong example would be Bill is either 20 or 21. You can't be both. So we use the wedge to represent the weak sense of or, and if we need to represent the stronger sense, then we can say one or the other, but not both. But not both. And that's the strong sense of or. Now, a disjunction is false only if both statements are false. That is, as long as one of them is true, the claim that either or is going to be a true claim. So if they're both true, then the disjunction of two statements is true. And as long as one of them is true, the disjunction of them is still true. Again, the order doesn't matter. As long as one is true, the statement is true. But if both are false, then the claim that either one or the other is true is wrong or false. That's the truth table definition of the wedge. Now, what does this say? Not the case that either A or B, or neither A nor B. Whereas this says not the case that both A and D. And just to mention, the word and doesn't always have a true functional meaning. In a sentence like this, you come near me again and I'll call the police. The word and is not meant as a dot. It's in fact got this meaning in English, that if you come near me again, I'll call the police, which is a different kind of sentence altogether. This kind is exactly the kind it is. It's a horseshoe. It's a conditional statement. The horseshoe, this an arrow pointing to the right-hand side, represents if-then. And these are some other ways you can say if-then. If A, then B. A in case B, or A given that B, and A only if B. The car will start only if there's gas in the tank. Notice this, we'll have to talk about the kind of conditions we're talking about. Only if there's gas in the tank. Gas is in the tank is in the consequent. The car will start is in the antecedent. Only if is in the middle of the statement, and it goes where the horseshoe goes. If comes at the beginning of the statement, and it introduces the antecedent. So we call these material conditionals because they're about truth value. And here's a good way to understand when a material condition is true. Here's 4 possibilities for the statement that you might see on somebody's syllabus that says, if you get an A on the final, you'll get an A in the course. This example comes from Patrick Hurley's Concise Introduction to Logic. So let's assume that in the first case, it's true that you get an A on the final, and it's true that you get an A in the course. You'll be happy and you'll say, he told the truth. But let's assume this case, you get an A on the final, but you don't get an A in the course. That sentence is false. Then you're going to say, he lied. That claim was false. But if you don't get an A on the final, in this third case, and you do get an A in the course, you're not going to have any reason to say he lied or that statement was false. And if you don't get an A on the final and you don't get an A in the course, again, you have no reason to claim that the statement made was a lie. And those are the conditions under which we're going to say a conditional is true or false. Namely, a conditional is true unless its antecedent is true when its consequent is false. So whenever a false antecedent is present, you nonetheless have a true statement. This is what that truth table is going to look like. If both are true, it's true. It's false only if the antecedent is true when the consequent is false, and it's true even if the antecedent is false. And just consider a sentence like, if I'm 10 feet tall, I can touch the ceiling. I'm not 10 feet tall, that's false. I can't touch the ceiling, that's false. But it is true that if I'm 10 feet tall, I can touch the ceiling. A sufficient condition is expressed as the antecedent of a conditional, and the necessary condition is expressed as its consequent. And the word son should be useful to you to keep that in mind, because you can turn that word, the letter U, on its side and think of it as the horseshoe, and that reminds you sufficient comes first, necessary comes second. You have to have a college ID to get into the show, means getting into the show won't happen unless you have a college ID, so having a college ID is necessary. That means you're going to put C, having a college ID, in the consequent, and write, if you can get into the show, then you have a college ID. Here's our last symbol, the triple bar. It represents the phrase if and only if, which is called a biconditional. It's called a biconditional because there are two conditional statements linked together, P if Q and P only if Q. For example, you're President of the United States if and only if you are Commander-in-Chief of the Armed Forces. That means you're President if you are Commander-in-Chief, and it means you're President only if you are Commander-in-Chief. If you are Commander-in-Chief means that's a sufficient condition. Only if you are Commander-in-Chief means that's a necessary condition. You are President if your Commander-in-Chief is going to therefore be represented as C implies P, or C horseshoe P, where C is Commander-in-Chief. But you are President only if you are Commander-in-Chief is going to be represented P and horseshoe C. You put those two together with a dot. C implies P and P implies C, and you have what we call the triple bar, P if and only if C. So here is then an equivalence. The biconditional, or the conjunction of two conditional statements, can be written as a triple bar. That's an abbreviation for this longer formula. They say the same thing. And here's how the truth table will look. Because we know that a conditional is true as long as both parts are true, and a conditional again is true as long as both parts are true, and now we have a dot. Well, the dot is true if this statement joined with this statement is true, and they're both true, so the dot is true. So we're going to say when both parts are true, a triple bar is true. Now here's a case where the antecedent, the P is true, but the C is false. So this conditional statement is false because true antecedent, false consequent yields a false statement. But here we have a false antecedent and a true consequent, so we get a true statement. Now we have to figure out the dot. Well, the dot is going to be true only if both parts are true. This part's not true. This part is true. That makes the dot false. So a triple bar statement is false if one part's true and the other part's false. That's going to happen again if the order is different. We have one part true and the other part false, and triple bar is false. And then notice this: if both parts are false, the claim that they are necessary and sufficient for each other is true. And here's why. False implies false is true. False implies false is true. That means we have a true statement and a true statement linked by the dot, affirming that they're both true. They are both true, so the dot has a T under it. So you notice that a triple bar is true when both statements are true and when both statements are false. And that means that the triple bar is actually the same thing as the phrase is equivalent to, because it's true when both of its parts have the same truth value. If they're both true, the triple bar is true. If they're both false, the triple bar is true. If they differ, then the triple bar is false. So it's a claim that P is equivalent to C in this case, which is true when they're both true and true when they're both false. Here then are the definitions of the operators by truth table, summarizing what we saw a minute ago. And you don't want to memorize these tables, you want to memorize the key meaning of the term, which is summarized in the tables, and that comes down to this. A tilde reverses the value of the statement it affects. It turns T's into F's and F's into T's. A conjunction is true only if both conjuncts are true. Otherwise it's false. A disjunction is false only if both disjuncts are false. Otherwise it's true. A conditional is false only when the antecedent is true and the consequent is false. otherwise it's true. And a triple bar is true when the two statements have the same truth value, otherwise it's false. Now, take a look at these statements I'm going to put up and see if you can determine quickly what kind of statements they are. That is, are they conjunctions, disjunctions, conditionals, negations, and so forth. That's an essential exercise to get accustomed to. That is a negation because the tilde affects what comes after it, which is a unit beginning at this bracket and ending at this bracket. This is a disjunction because this is a unit beginning at this bracket and ending here, and this is a unit beginning at this parenthesis and ending here, and the two units are joined by the wedge. This is a conjunction because you have a unit beginning at this bracket, ending at this bracket. You have a statement over here by itself, and the two are joined by the dot. And this is a biconditional because the unit over here begins at this bracket, ends at this bracket. The unit begins here and ends at this bracket, and the triple bar is joining them together. There are exercises in the text to practice with for this sort of thing. Punctuation is essential to be careful about, so here are some examples of looking at what's wrong with punctuation in a variety of sentences. As you read through this, you should see this makes no sense. The tilde is affecting a horseshoe instead of affecting a letter. That doesn't make any sense. And this doesn't make any sense either. The wedge is affecting the dot. That doesn't make any sense at all. In this case, what's wrong? The punctuation is incomplete. The bracket that begins here never got closed. It should have been closed here. In this case, the problem is you have a bracket beginning here and ending here, but you've got a curly bracket beginning here and ending here, and they overlap each other. That doesn't make any sense. You can't tell what the main operator of the sentence is. You can't tell if this wedge is the main operator or if this dot is supposed to be the main operator. In fact, what you can tell is that this makes no sense. And in this one, this is fine, this is fine, this is fine, but this does not make sense because you can't tell if this dot is joining this unit to this unit or whether this is supposed to be one unit joined by the dot to the tilde A at the end. So parentheses are needed here. Now the suggestion is, because this parenthesis is here, that probably this is the one where the parenthesis should go. But it's not necessary. It would be just as possible to have a parenthesis after this B, and then this tilde, this dot would be the main operator within this bracket. Here are some examples where I'm going to give you sentences and you choose a letter and you choose the operators to rewrite them into symbolic notation. Notice here that the letter P stands for Paul is a jerk. It doesn't stand for Paul. These uppercase letters always stand for a complete simple sentence. Notice that these are two different ways to say the same thing. They'd have to be crazy to get married. That means being crazy would be a necessary condition for them to get married. If they get married, then they're crazy. This requires a tilde. Bob doesn't take his umbrella. You can't. If you overlook that tilde, you're overlooking an important piece of the structure. It's negative. Here we have a conjunction as the antecedent. And E stands for Eve can spell, and A stands for Abel can spell. Here you have to decide what the main operator is. Either he controls the meaning of words, or else some of them are too expensive and he just has to accept that. Here you have to see that even though the statement here comes second, it's the if clause, and so the if clause has to be stated first. Also, it's a negative antecedent. So tilde P, if someone can't tell a cravat from a belt, then P, it's a most provoking thing. And this has two negations. You can't tell that unbirthday presents are better. You don't understand basic arithmetic. The or else makes it pretty clear that that's going to be the main operator. Here you have to do some thinking. It was invaded and either. The and is the main operator. We've seen that one already. Neither nor, a neither nor statement. Okay, let's take a look at that. If they have croissants, then as long as means if. If they have coffee, then I don't even want a Danish. So as long as means the same thing as if. So if C, then if O, then not D. Here you have a semicolon. That's going to be represented by a dot. D stands for Danish or high in fat. C stands for croissants or high in fat. H stands for you want something healthy, and B stands for you want a blueberry muffin. You should have a blueberry muffin.